So I guess whenever you're ready.
Great. Okay. Well, we thought we would start with a quick round of intros. There's the three of us here, and then Matt here from DLC will start explaining a bit about what our product is and what we do as a company before we get into the more technical stuff. So I'll start the intros. I'm Jesse. I'm CTO of DLC Link. Previously, I was doing more traditional software development at a couple of companies like Pivotal Labs and Twitter. And so this is my first time working at a decentralized blockchain development company. So it's been a really fun journey, and we've been at it for about a year. So just like many of the people here, there's not that many engineers that have been programming in this space for a long time. We're all new and we're all kind of learning together. So it's great and exciting to be here. And maybe Robert, you want to go next?
Sure, thank you. I'm Robert. I've been at DLC Link for about 2 months now, and it's my first blockchain dev job too. I studied astronomy before, but I've been really enjoying it. It's a lot of fun. Yeah, excited to share with you guys what we built. Matt.
Thanks, Robert. Hi, everyone. Matt from DLC Link. I'm the solutions architect and kind of business development guy here on the team. A little bit about me. I spent the past 4 or 5 years in a traditional financial technology audit and data analytics role. Picked up again about a year and a half ago into the blockchain space, just learning about decentralized finance, other smart contract platforms such as Stacks, and have been with DLC for a little less than a year now. So with that, I guess I can kind of go ahead and give a little overview on our company and our products. So so we're DLC Link. We have a mission to bring the smartest way to move and use Bitcoin to every blockchain and non-blockchain application, company, and retail user. So the main problem we're trying to solve here is that Bitcoin obviously lacks smart contract functionality. With its amazing proof of work security features come its limitations, which are that you can't move Bitcoin conditionally directly on the Bitcoin network. So how that differs from Ethereum and Stacks is that you can't write complex logic to automatically execute on a blockchain natively on Bitcoin. It's very good at keeping a balance of a ledger and transactions and payment of Bitcoin from peer to peer, but it lacks that if this then that outside of a few clever ways using time locks. So what we're doing is trying to enable smart contract functionality for conditional Bitcoin payments orchestrated by any other blockchain such as Stacks here. So I'll go into just a little bit about the actual kind of cryptography and how this works. Discrete log contracts are a simple 2 of 3 multi-sig. If you're familiar with multi-signatures, multi-signature wallets in the Bitcoin network, where 2 parties lock in a certain amount of Bitcoin and they wait for this third party, an oracle, we call that, to attest to some kind of condition that both parties agree upon. So in the simple case of Alice and Bob bet on a sports game, they both put their funds in, and the oracle is, say, Yahoo Sports outcome, and they win or lose that bet accordingly. The difference here is that with protocols such as Ethereum and Stacks, that these funds that Alice and Bob are locking go to some other contract, or they have to send it to another party or wallet. In this case, the Bitcoin remains with Alice and Bob in this multi-signature wallet until the outcome of the oracle is announced and the Bitcoin is moved and settled to either Alice, Bob, or some combination of both. So how DLC Link, how we make it programmable, is that we have decided to build the infrastructure around orchestrating this opening of a DLC agreement and a closing of a DLC agreement by smart contracts. And so again, if you remember that the Bitcoin never leaves or gets wrapped or moved or sent to a custodian during this time, we needed to make that infrastructure so that a smart contract platform can interact with the users and give them the appropriate transactions to sign directly in their wallet, directly on the Bitcoin network. So in the generic sense of how do we make this Bitcoin programmable, but non-custodial and basically like an escrow, but within a wallet and not a third party, is that when these two users sign the DLC link transaction, their Bitcoin is locked until a outside source of those users choosing, such as a Stacks event outcome, which I'll let the incredible dev team here kind of explain how that works, announces that the DLC is closed and the Bitcoin then gets moved, such as here in step 3 to a party or both parties, or again, some permutation of that. So with that comes a lot of exciting possibilities about how people can construct transactions, smart contracts, agreements, settling in Bitcoin. So just some of the very basic things that we've kind of touched on, and what our product is especially focusing on is more of the financial aspect of escrow. Meaning normally in a, if you're buying a house or a car or some kind of transaction where you need to lock money away to prove that you have it so that the counterparty knows that they're not dealing with an empty promise or someone who's broke. There's usually a third-party agent that collects funds and holds it there and waits for the user, the two users, to say, okay, we've finished our non-blockchain agreement, such as a sale of a car, an exchange of goods or services, or even a smart contract outcome. And then that third party releases the funds and sends it to the users accordingly. So obviously there are many Bitcoiners. I don't like to use the word maxis, but there are a lot of Bitcoiners out there that really are not welcoming and opening to sending their Bitcoin to another party, for the risk of that person doesn't have to agree to ever, or the party that has the Bitcoin is never really held accountable, in that they could just run away with it or send it. It's locked in their wallet. The user no longer has custody of it. So what we're doing again is just building this network of oracles and smart contracts in order to allow the user to retain custody while doing all these amazing things about it. So one specific kind of example that we like to share is a lending use case. So if you can think of the Xverse wallet or a Bitcoin and Stacks wallet that you're familiar with, one could potentially navigate to a protocol such as Archidico. And in this scenario, before I kind of click through it, what we're aiming to do here is locking Bitcoin as your deposit collateral. So no different than a Aave on Ethereum or a Benki on Avalanche, or in the traditional sense here on Stacks, Archidico, locking your Deco tokens or Stacks and borrowing USDA on it. What we're doing here is, again, we're using Bitcoin as collateral, but not having to send it through a bridge or bridge to XBTC or give it to another custodian to hold while this takes place. So what this would look like from a user perspective is that they go to click lock on their in their Xverse wallet, and it prompts them to put in a certain amount or how much would you like to lock. This can also happen natively on a Web 2 like server or a front end, but then the person would lock PTC. And then the Xverse wallet pops up with a Bitcoin transaction, because this is, again, not bridging, this is not moving Bitcoin to another chain or another smart contract platform. It remains in a DLC transaction offer signature, or just a Bitcoin transaction signature, and then they lock it. So now on the application front end, you'll see that Archidico has noticed or has gone into an agreement with the person or the user and the protocol to say, okay, yes, we see that you've locked Bitcoin in this escrow contract. We don't have it, you don't have it, but it's not in a bridge because it's locked into a multi-sig. Now you're allowed to borrow stablecoin, Ethereum, Stacks tokens, or whatever other fungible, non-fungible token that you'd like. So that's our main product, and obviously we have other ideas to increase the functionality of this, minting NFTs that are backed by Bitcoin, or just in the general sense of anywhere you'd like to use a conditional Bitcoin payment, whether that's on Stacks or an application that's on the back end powered by Stacks, but is invisible to the user. We like to think that we are the we're one of the ways that you can non-custodially, trustlessly eliminate counterparty risk with moving Bitcoin. And the users are happy that they're able to engage in these kind of transactions. And we'll get to probably questions in a bit. So I'll leave that to Jesse and Robert, but I wanted to get to them to the actual core clarity stuff to get more further in the details of this. So with that, I'll pass it off to them.
Cool. All right. Thanks, Matt. Yeah, I see some questions coming in already. I'll jump into the technical flow now, which I think will clarify some of these, but then separately, I think if it's okay, we'll probably do a Q&A towards the end. Just queue up all the questions and go through. Great. All right. So let's share this one. All right. Am I sharing the right thing, Robert? To the flow? Yes. Okay, great. Cool. So I'm going to step through what Matt was describing, but more from the technical side. So this is our architecture. One of the components on here will be our Stacks Clarity contract. But this is kind of giving the full picture. I thought it would be nice to go all the way from the application to hear the technical overview before we look at the Clarity code, although we can bounce back and forth between those last two if we want to. Because it shows, it's kind of nice to see what the purpose of the code is, to kind of get a top-down view of what the code, what it was designed to do as we're going through it. Starting at the upper left, I think you can see my cursor. We see the app, similar to what Matt was describing. Here we are. We want to take a loan. We want to take a stablecoin loan. But in this case, we don't want to use Ethereum as collateral or a different stablecoin. We want to use Bitcoin, and we don't want to use wrapped Bitcoin. We want to use native Bitcoin. This was kind of the purpose of the invention of the discrete log contract, was locking up Bitcoin conditionally and letting these oracles decide how it gets paid out. And that's why we're building in the Stacks ecosystem, because the cultures are so well aligned for building smart Bitcoin related tools. So the user goes through, says they want to take out a loan. They're going to lock Bitcoin, native Bitcoin for that. In this case, we're using Arcadico, which is a DeFi lending protocol on Stacks. We're using that's a little icon here. So now Arcadico contract, smart contract and Clarity, is what the user is interacting with. And this is often how we will do our, this is how our product works. This is how it's designed, is that the user's interacting with a smart contract to set up some kind of a game, a bet, a loan, in this case, a loan. And that smart contract is going to call in to our smart contract using a series of public functions and traits, which Robert will describe shortly. So the DeFi protocol calls into our smart contract, initially calling the open DLC function, essentially. So you want to open a DLC, and that's where the user is going to, the result of that is where the user is going to lock their Bitcoin to. There'll be an address there. The user will lock the Bitcoin into the address. I saw a question in the chat about, is there gas fee? And the gas fee on the Bitcoin chain happens, yes, when you send your Bitcoin to the DLC address, which is very much like a multi-sig address. The sending of it has the gas fee, a very simple gas fee, similar to just sending Bitcoin to any address. Signing the DLC with your wallet does not have any fee associated. So, and here's the backend architecture for our system. So the protocols smart contract, Arcadico in this case, talks to our smart contract. We then use the stacks.js JavaScript library to listen to those events. And we call that our listener agents here. And those are communicating with the DLC oracle. The DLC oracle has to be off-chain because it has a private key that it uses to sign these transactions and sign the potential outcomes that are allowed for this contract. In this case, the potential outcomes are going to be the price of Bitcoin when the contract gets closed, whether the user is returning the loan amount and getting the Bitcoin back, Or if for some reason the price of Bitcoin drops, which I guess it can do, and we need to do a liquidation event, we're also checking the price of Bitcoin there. So this is what the DLC Oracle will attest to, the price of Bitcoin eventually. So that's off-chain because it needs a private key to do those signatures. And on-chain principals cannot have private keys. Like you cannot have a private key associated with the smart contract itself. You need something off-chain for that. So the communication goes to the DLC Oracle through the Stacks.js listeners back into the Stacks blockchain. And now the DLC is opened, and that communicates back to the protocols contract as well, saying, okay, the DLC is open. The user can now send, see that in their wallet and send the Bitcoin on the Bitcoin network to that multi-sig, to that DLC, locking it up. And once the protocol's application and smart contract have seen that Bitcoin has been sent, which is something Stacks does very well, which is being able to read the Bitcoin blockchain. So it will see that the Bitcoin is locked in the DLC. Then Arkadika reports to the user, the app reports to the user, okay, we've received your collateral of native Bitcoin. We can now issue you a loan of some stable coin on Stacks. I think that's about it to show here. If there's no, let me see if there's any questions very specific to this that I want to show. Great. Answering some questions about Lightning. Okay, perfect. So I'll hand it over now to Robert, but we can always come back to this diagram later if we'd like.
Thank you.
Yes, so the Bitcoin, just to answer that last one real quick, the Bitcoin does have to leave the user's wallet, but it goes into a multi-sig where it's locked away between the protocol and the user. And that's why we say it's non-custodial, because you're never handing it off to somebody that you trust. It's cryptographically locked in a multi-sig, so that it's safe while you have this loan outstanding, and only the Stacks Clarity smart contract can decide how to unlock that money later. And that money either comes back to you because you repay the loan, or it goes to the protocol because the price of Bitcoin dropped and you get liquidated. Okay, sorry, go ahead, Robert.
No, thank you. Yes, so thanks, that was great. We actually have 3 different contracts currently, and I'm just saying this because we talked about the loan flow just now, but I will actually be showing the simplest contract because the loan one is very complicated, but all our code is open source, and on our GitHub we'll definitely drop links here in the end, so please read those. All right, let me share my screen. One sec. Oh, wait, I just installed Zoom, so I'm gonna have to quit. I'll let you guys answer some questions. I'll be 1 minute less.
Okay, go ahead, Robert. What do you see, Matt? Any questions you want to answer out loud?
Yeah, I answered the one about the Lightning. So I guess one thing I do want to clarify, because this usually tends to be a pattern of questions around DLCs, is that the counterparties are always Bitcoin addresses or Bitcoin wallets. That is the fundamental reason why we're kind of building our product, is because when someone says, oh, can the counterparty be a smart contract? Can it be this? The discrete log contract exists solely between 2 Bitcoin addresses. And it's how you want to think of constructing what that Bitcoin address is, whether that's controlled by a person, a protocol, another group of users holding a Bitcoin multi-sig. The 2 parties that are holding the Bitcoin in this non-custodial escrow Bitcoin contract, it's a UTXO, are Bitcoin addresses. It's how the unlock and how the funds get orchestrated or how they move based on certain conditions that we leave the logic or the conditionality of these payments about when that safe Bitcoin can be spent into the hands of Clarity developers. So hopefully that answers a few questions at once. And after Robert goes through this, we can always chime in for some more.
Thank you. All right. So the first thing I wanted to mention actually is that, can you guys see this screen too? What I'm showing right now, the technical flow? Yeah, cool. So one question could be why we even need a smart contract for this, because we could very easily just let the protocol interface with our DLC Oracle system. That could be a setup. But of course, it was important for us to, and then make Web2 API calls back and forth and just send DLC data that way. But we decided to build smart contracts so that all the data is completely verifiable on chain. You can follow the flow of information through the system. And this, I'll get back to this when I'm talking about this, but this was the reason why we basically built smart contracts and why we store some state and some data on chain too. Now I know watching code on screen is not the most exhilarating thing to do, but I will be just focusing on a couple of interesting things that might be interesting as Clarity developers for you guys. So one of the first things I wanted to show is how we are using NFTs. We store information about our DLCs in maps too. You can see it here. So data that's useful on chain. But the problem with these hash maps is that you need to know the keys to access the information. So it makes it very hard to, for example, iterate through them. Well, it's basically impossible. And so it's very hard to query data, to get all open DLCs. So we use the solution of NFTs, which are first-class citizens on Clarity. And it's very easy to query them using the Stacks nodes and like the Stacks.js library, for example, in JavaScript. So this is awesome because we can just mint and burn and query this information very quickly and very efficiently. And I'll show you how we actually do this. We use two NFTs in this contract, one for keeping track of open DLCs and one for registered contracts. And this is another interesting aspect I wanted to showcase. It's a limitation of the Stacks nodes and its APIs that you don't hear function calls coming from another contract into your smart contract. There's been work regarding this. You can see it on GitHub. There are issues opened and closed, and there is work going on to fix this, to implement this basically. But as a workaround, what we did was we make our protocol, so our customers' contracts, smart contracts, we register them on chain and through the chain on our backend infrastructure. And then we will start listening to their function calling into ours. I'll show you the bottom of this contract. We have three functions regarding this. You can register, unregister contracts and the helper function to check if this is registered. Once again, we are using NFTs here. So when you register, we mint an NFT using the necessary information, or we burn it when you unsubscribe. And we use the NFTs, these awesome stacks, Clarity built-in functions to handle this easily. One interesting thing you can notice here is the way we pass in these protocol contracts is using a trait. This is our callback trait, and I will get back to this in more detail and how we use this. But it's important to note, and I think it's interesting to note that if you use it this way, this basically forces us that we can only register contracts of this type. So this is very strongly typed this way. Even on chain. So if you try to register a contract which doesn't implement this trait, then this transaction is going to fail. So this way we can ensure that we interface with the right contracts and they interface with ours properly. So yes, let me just go through the general flow real quick of how this contract works. We have one public function for creating DLCs. This is very simple. It takes in required information about DLC, and it simply prints it out and some extra stuff. This is as simple as programming can get. But why this is interesting is that these print events are what our listener infrastructure is listening to, surprisingly. And basically our listener infrastructure takes this data, stores what we need to store, handles what we need to handle, and calls back on chain into the create DLC internal. For example, one thing that is coming off chain is that, of course, this is a public function, any smart contract or can just call it or script, but they give us a callback contract. This can be the same as the transaction sender. So of course, if it's a smart contract, it would pass in itself. But the point of this is that we will want to hand back information. For one thing, we definitely want to hand back that this whole process was successful, the DLC was created. And also we will hand back information so that they can access this DLC later through a unique identifier that we generate on our backend. All right, so our system calls the internal function, the same information. There's some checking here. I don't want to get lost in the weeds here too much, but the interesting part is right here. So this is where the traits, this trait becomes very important, because in this call, we will call back into our protocol contract, this contract that they either provided or is the actual creator or caller of our functions. So for this, we need to be sure that they implemented our post create DLC handler function. And before I jump to that, just one more thing. This is where you can see that at the end of this, we mint this open DLC NFT, which is identified by this unique identifier. Yes, so the trait, we enforce that the callback contract implements this trait. And wait, let me just, all right, so yeah, here's the trait. It's a very simple trait. On some of our other contracts, it's a more complicated one, but that's why I wanted to show this one. This is one single function defined that we expect our protocol contracts to implement. And it's this post create DLC handler function. And this is just used basically to hand back the generated unique identifier. Yes, okay, so this is cool. And also, before I move on too much, no, actually, let me just move on. So let's see the closing flow. In this simplest contract, we don't have any price data. We don't have anything fancy. The close DLC function is called with a unique identifier and an outcome. This is interesting. This outcome is a number between 0 and 10,000, unsigned integer, of course. It's clarity land or blockchain land. But this is really representing 0 to 100 with 2 decimals precision. So any number between 0 and 100.00 for like 2 decisions. Yeah, anyway, you get it. And this number is going to be used to sign. So this value will be signed on the payout curve of the DLC. I know we didn't get into details of DLC payouts, but the simplest way I can put this is if this number is what divides which party gets what percentage of the locked Bitcoin. So if it's 70, then 70% goes to Alice and 30% goes to Bob in this Bitcoin contract. So yes, in this simple setup, this simplest contract, we expect this to come from our user. So from the protocol, like Arcadico would tell us that close it with this amount, close it with that amount, and we just do the things. Of course, there's a ton of asserts here, which I don't want to get into. It's just checking that you're authorized and all the things. And then, of course, we burn the NFT. In our more complicated contracts, and I'm just going to show it just to show why I'm not showing that one. For example, this one is using price data. It has an internal close function called by us, which is using Redstone price feed data. So it fetches the price of any asset. Actually, it doesn't have to be Bitcoin. So it can use whatever. And then there is a ton of extra steps to ensure that the data is actually coming from Redstone, is checked on chain. But anyway, read this on our GitHub for sure. We'll be very interested to see what you think. Okay, and one more interesting thing I wanted to mention is you might have noticed that all of our prints contain this funky looking line, event source. And we are using this solution in all of our print events. It's a very strictly uniform and very peculiarly, or how should I say, consistently formatted string, which we use to filter out, to track events on the blockchain, which we make sure it's related to our contract. This was born slightly out of necessity because of the contract registration stuff. So, we are listening to protocol contracts events as well, not just our own. And these prints actually flow through. So if your contract calls another contract, if you look on the Explorer, then you will see print events coming from the other contract, of course. So this is awesome for us because we just put this in all of our function calls and we can track, we can follow and always see and always hear if somebody interfaces or uses our contract. And I think that's all I wanted to mention. Yeah, I'm going to open the chat because I see there are things. If you can check transaction standard and contract color, they should be different. Can't you understand from there? Well, in some of our implementations, they actually have to be the same. So if it's, wait, what do you mean? Actually, I'm not sure I understand this question. If you mean the open, like create DLC, this has a creator and as the transaction sender, and the callback contract is callback contract. I thought you were talking about this because this might actually change in the future. I don't think we need this. Yes, okay, you mean this. Yes, so very good question. It could be the same. I mean, it is the same in this, for example, in this current implementation, but not necessarily. Not necessarily, because you could call this from a script. You could have your own Stacks.js scripts and interfaces and whatever talking to a contract, and you could be passing in a completely different principle here. Yeah, welcome. Can you show us the Stacks.js for the listener of the print statement? Well, yes and no. Wait a sec. I'm actually just working on some stuff, but wait.
I guess there was a question from Matt H around beyond collateral value amount. Do you qualify the user to pledge for a transaction? Can you? I don't know if Jesse or Robert understood what that was asking, but Matt, if you can clarify a question. I'm happy to mull it over as Robert continues.
Yeah, Yeah, I'm not sure I understood that just now, but yes, if Jesse has an answer to that, I can.
Sorry, go ahead, Robert.
Yeah. So the observer code is actually being refactored now heavily, but I'm still going to show you the current live version. And it's very simple in the sense that we use WebSockets, the stack socket setup.
Robert, we can only see your Clarity code now.
Oh, wait. Stacks observer. Yes. What about now?
Yes, got it.
All right, cool. So this is a bit messy. It's anyway. I'm gonna apologize, but this is going through a major effect right now. But anyway, the point is, to answer the question, is we use the Stacks API socket client. This is a WebSocket setup, and it's awesome because you can just keep adding subscriptions to it. So actually, it's interesting we brought this up because, for example, right here, you can see how we are easily fetching all the NFTs for a given from a given contract, and we use those to quickly load all the registered contracts which are talking to that. Anyway, this could be another half an hour if I start talking about the listener too, but basically, sorry, yeah. So we just hear all the address transactions, and then we start filtering through it heavily and fetching, and yeah. Does this satisfy your curiosity? Or
Robert, do you have any post condition checks here?
Yes, it's in the listener code, because when you,
and maybe you can describe just in case not everybody knows what's the point of a post condition check, and maybe showing one.
I'm just thinking that I think the simple one doesn't even have post conditions, but yes, Stacks and Clarity uses post conditions to well, basically to enforce scripts. It's like extra security steps. I don't know much about post conditions. I use them, but I'm not sure I can explain them. But the point is, if you are doing on-chain transactions between contract and contract, that's all done automatically. You don't have to deal with the post conditions. But if you are scripting, you do. Okay, wait, let me open.
So it's something like type checking after calling into or receiving a command from a blockchain transaction.
The one we do, for example, is okay. Let me just bring it up. So the one we do as post conditions is when we are closing. Just a sec. So when you burn an NFT, for example, that's what I'm trying to get at. When you burn an NFT, there is a post condition. Yeah, right here. So, but there is this is an awesome library for that. The Stacks.js library basically has this all covered. So for example, if you make a transaction on chain from a script, which burns an NFT, you have to supply this post condition, which basically makes sure that at the end of this transaction, someone is not going to own this. In this case, it's, yeah. So in our case, this check means that, yes, it was burned, and yes, this contract doesn't own this NFT anymore. But this same thing, same but different, applies to if you would be sending tokens, like fungible tokens like STX or any token. There are post conditions for that, so that works the same way, but it makes sure that this recipient has it and the other doesn't anymore. Does that answer your question?
Yeah, thank you. Yeah, so it's different. It's a different, what the post condition is for depends on what the function's doing, but you need to, when you're calling from scripts, you need to, a function might require that you verify some post conditions for it, and so you pass a function and do that here. Okay, great.
Yeah. Question: do you have thresholds or requirements that individual users must qualify or reach?
Yeah, I think I can take that one. I think this is for the loan, for entering into the loan, if that's correct. So, you know, actually, generally, that's kind of the beauty of DeFi financial applications and loans, is that you the only requirement necessary is that you put up enough digital collateral to support the loan, and if you do that, then you're good to go. There shouldn't be any identity checking or any other background or anything like that. All the code for whether or not you're allowed to get the loan and the details of the loan is written into the Clarity smart contract by the protocol. So everything is in smart contracts and totally anonymous. As long as you have the Bitcoins to put over, you get the loan. And Robert, actually, you could answer that one. Are there boilerplate examples?
Well, no. Oh yeah, actually, sorry. Oh no, the listener, no. The listener in its current stage is closed source. That's the only thing we haven't published to the public yet. But one thing I forgot to show, and this is a good reminder, what we do have examples of is how to interface with our contract. So if you look on our repo, we have a sample protocol contract, which is a bare bones, very simple implementation of interfacing with ours through a smart contract. So for example, you can see we are using the trade, how we are using it, how to call into, wait, why is my screen sharing paused? That's...
Yeah, Rose.
It's just saying your screen sharing is paused, and okay, just a sec. Thank you, Mr. All right. So yes, sample, you can see it now, right? It says it's good. Cool.
Yeah.
So sample protocol contract, in the repo, you can find it under the examples folder, and you can see examples here of how to call our contract, for example. So yes, but the listener, no.
Although I guess, Robert, maybe, right, so this, the code you're showing here is how a protocol, a different Clarity smart contract would interface with the DLC link smart contract.
Yes.
But
yes,
maybe there's, I'm sure there was somewhere when you were writing listeners, there must be some Stacks.js examples online.
Yes, if that's what you mean. So yes,
Maybe that would be helpful.
Our smart contracts repos also have a huge scripts folder always, where you can see examples of how to, actually a bunch of stuff. But yes, here is an event listening. I'm not sure how up to date this is, since we have our own separate listeners. But now that there is interest for this, I will update this to be very up to date. But yes, but event listening, that TypeScript, and you can see this very bare bones, very simple explanations. And yeah, good question. Yes, thank you. And there is a lot of scripts here as well, where you can read how we can interface with our contract. Basically, our listener code is just a fancy way of connecting a bunch of these scripts together into one big project. But I thought the question was more like, I mean, this is interesting as well, but Jesse, maybe you could talk about the like the oracles and decentralization, because that's also not open.
Sure. Yes, there was a question about the oracles, and I think how are they secure? How are they decentralized? Yes, I don't see it exactly, but yeah. So the oracles, the Bitcoin oracles, or DLC Bitcoin oracles, will operate somewhat similar to either to a multi-sig you could imagine, meaning 2 of 3 private keys needs to sign before a transaction's allowed to go forward, which is also sort of in a way like how a set of decentralized nodes like Stacks nodes or Ethereum nodes might work, right, through some consensus algorithm. So for now, we have one. We're still kind of building out our first prototypes, but we've got one DLC oracle signing outcomes. That could be a problem because although the oracle cannot, it's not participating in the DLC. Two users are, or maybe one user and one protocol, and the oracle can't steal the money. But theoretically, the oracle could collude with one of the users to steal money together. That would be a problem. So a bad actor per oracle, or maybe the oracle just the server goes down or the private key is lost and then it's not there to sign the outcome. So normally we would handle that by having a 2 of 3 or maybe 3 of 5 or 4 of 5 oracle signatures required in order to close the DLC. And so again, it's functioning sort of like a multi-sig. Like if the user requires a very high level of assuredness, then they might require 4 or 5 oracles to sign in order to close the DLC. That all 4 or 5 have to agree before they would close it. If one of them disappears, you still have others that are there to close it. Yeah. So if you have any other questions on that, I'm happy to answer. And those nodes wouldn't only be, of course, run by one person or one company. In theory, they should be anonymous and decentralized. Anybody can, we very much hope that we get this to a state where anybody can run their own node and participate in the signing process. So DLCs do not allow previously, it's rather difficult to modify a DLC once it's been created. If you have 2 users that have entered into a DLC, and of course the oracle will attest to the outcome, all the participants have to be present in order for someone else to join the DLC and for someone to leave it. So it's rather, it can technically be done, but it's rather tricky. So that's not something we support currently. I noticed a quick question I can take is Hero Wallet supported? So actually currently we're demoing visually with the Xverse wallet because we know it's on their roadmap to support DLCs, and they currently support both Stacks coins and Bitcoin. So that's just kind of a cool demo, but they do not currently support signing DLCs. Only our prototype, like custom wallet, does. But we're hoping to get integrated into Xverse very soon. Hero as well. We'd very much love to get integrated into Hero, and we're talking to that team. They are working on getting Bitcoin integrated into the Hero wallet. I believe that's on the roadmap, and then we can, because DLC is a Bitcoin technology, it doesn't make sense until they support Bitcoin. So it's on our future agenda. Matt, you got any queued up that you want to take, or Robert?
No, I think we see one about how do you get information from the Oracle in? Again, maybe Jesse and Robert can explain this better, but we as a Bitcoin Oracle, we are listening for the customer or the user or the smart contract in this case to describe to us what that contract would like to attest to. So to answer that question, I guess kind of literally, how do you get information in? It's through our smart contract, and that would describe all of the conditions as Robert was mentioning, whether it's I would like the DLC.link Oracle to attest to this number I'm going to feed it, or a price feed, or some other variation of that. So to get information into the Oracle to build the attestation, is through a smart contract.
I think this question might, I mean, this was a very good answer as well, but from another direction, if I understand it correctly, currently the attestation, so the end result, is not going on chain. The attestation is currently available only as a Web2 API call through our system. So, but we are actually planning on adding that. I don't know, Jesse could talk about it more, but yes, we are planning on adding that the attestation is then somehow also checked on chain, but currently it feels a little bit overkill because the Oracle has no incentive to be malicious because it cannot win anything out of it unless it colludes with one of the participants, I guess.
Yeah, I mean, I noticed somebody who mentioned that perhaps they could just do this in a smart contract. I'm not sure if I understand exactly if that was a question, but you know, specifically with the DLC technology is for Bitcoin. It's a way to sign Bitcoin in such a way that it can't be the Bitcoin can't be sent on out of that multi-sig locked contract until an Oracle attests to an outcome, and our Oracle attests to outcomes that are from Clarity smart contracts. So in a way, we're using Clarity code to power the movement of Bitcoin. So that's why we call it like Clarity powered smart payments for Bitcoin, something like that. So that's the very high level view of what we're doing. Oracle price feeds. So our oracles are currently free, and actually when we're pulling the Bitcoin price, if this helps answer any questions, our oracles will sign an outcome that is currently free and in testnet, and we pull the price of Bitcoin. And currently we're using a data oracle system called Redstone, which is very much like Chainlink. If anyone has heard of Chainlink, it's a great way to get price feeds for various coins. And that also is free, at least in testnet, I think even in production. But I would expect both of these services to have some kind of a token related fee associated to them in the future, both pulling data from Redstone as well as paying these node operators to sign DLCs. That'll be their motivation for behaving properly and for getting many to participate so that we can have like the 3 of 5 kind of signatures. I think that might be it, unless you guys see any others. Okay, one more just popped in, but if we missed anyone else from earlier, please type it again because we might have just missed it. That's a great question. Yeah, I don't think either Redstone or us has figured that out exactly yet, what the payment style would be like. It would be very cool if we did something like Chainlink. But yeah, we're very much like looking for feedback from the community and figuring out in the long run what's going to work best. For now, we just really want to get this technology out there. It's going to be great for hopefully for all of Web3 and certainly for the Saks teams and ecosystem. So that's our primary mission now. Yes. Right. So generally a smart contract calls in to our smart contract, but the DLC always needs to be connected, as Matt was mentioning earlier. The DLC has to be entered into from 2 different Bitcoin wallets, 2 different Bitcoin private keys. So in our example of a DeFi protocol that is doing loaning and taking Bitcoin as collateral and giving out loans, that protocol would have both a smart contract, which interfaces on chain, manages the loan, and connects to our DLC smart contract, pardon me. And that protocol would also have a Bitcoin wallet, which they probably control in their backend servers. It's got a Bitcoin private key, and that's the part that enters into the DLC. So entering into a DLC, always a Bitcoin private key, a Bitcoin wallet. Separately, a smart contract is needed.
I think a good way to think about this, which might answer these last 2 questions, is that we are basically building a multi-chain, cross-chain messaging infrastructure. So the DLCs really can only exist on Bitcoin. And it's a Bitcoin technology, it's living on Bitcoin land. But the DLC link infrastructure can interface with any other smart contract and any other chain. So we are building on Stacks, we're building on Ethereum, and whatever in the future, Solana, if it doesn't stop. So this is always between two chains. One of them is the native OG Bitcoin chain. And yes, Bitcoin doesn't have smart contracts at all. Oh yeah, that's Jesse writing, all right. Who can I DM? I don't know, shall we just drop in emails here or?
We've got a Discord link.
Yeah.
Join our Discord and ask any questions you've got. We've got more learning available there too. And let's see, does anybody know how to grab a link to our Discord, a public link?
Yeah, maybe Akanksha, we can send you our social media links, Discord docs, all that stuff, and if you could disseminate those to the group as well. On top of this, I think most people will be able to find us one way or another. So
Yeah, that sounds great.
awesome.
Thank you, team. I think this was very insightful, not only for the participants, but Chiara and I as well. I know I had a quick chat, both of us, we had a quick chat with Aki in one of the sessions, but today was extremely helpful in, connecting all the dots that he was talking about. And I think this has great potential, and hopefully our audience, they liked your product as well. And hopefully it was helpful for them. But great content and presentation. Thank you so much.
Yep. Thank you for having us. Glad we could be available today.
Thank you, guys. It's good to be
Yeah,
here.
thanks everything. It was a pleasure. All right. See you all in
Yeah.
Discord.
Someone is asking for contract. You can find them in the dev channel on our Discord actually, but I'll update them. Yeah,
Oh, perfect.
thank you.
Thank you so much.
All right. Thanks,
Yeah.
guys.
So.